Alright, so we're going to begin sections 2.4, 2.5, and 2.6. Actually, we're only going to talk through sections 2.4 and 2.5. So this video will cover the first few slides from this section, and then the next few videos will get us through section 2.5. 2.6, we have sort of talked about it a little bit along the way. We're not going to go into that chapter, the things from that chapter that you need to know. We've either talked about already or we will talk about in some future sections. So just kind of be aware of that. If you look at the PowerPoint, obviously it says 2.4, 2.5, 2.6, but we're not going to do the 2.6. So just want you to be aware of that. So we are shifting gears a little bit from where we've been, but not a whole lot. In the earlier parts of chapter 2, we've talked about functions, and we've talked about circles, and we've talked about some basics of graphing and some of those things, and how to graph different types of equations and all that. But now we're going to get into specifically dealing with linear equations and linear functions. And so there's some terminology that you need to know, and a lot of this is going to be stuff that you know already, but I do need us to see this. So the first thing is a linear function. A linear function is a function, we'll call it function f. We'll say that it's linear if for all real numbers, a and b, f of x is equal to ax plus b. Now, remember in section 2.8, I believe it was, we talked about function notation, and maybe it was in 2.3. Anyway, one of our previous sections, we talked about function notation. We said that f of x and y are the same thing. So this is the same form of the equation y equals mx plus b that you're very familiar with. B didn't show up. You're very familiar with that from beginning algebra if you took that class, or if you've taken any other math class before this one, you've seen linear equations, linear functions. And so instead of writing it as y equals mx plus b, we're only focused on that second half of it, the right-hand side of that. And so the ax plus b. We do y equals mx plus b more for graphing purposes because the m is our slope, but now we're not going to worry as much about the slope. So just kind of be aware of that. Now, notice that our next little note here, if a is not equal to 0, so it's positive, it's negative, whatever, then the domain and range of the function are both all real numbers. Everything from negative infinity to positive infinity. So we're not going to really focus on finding domain and range a lot, because for most linear equations, and I know I've mentioned this in previous sections, most linear equations have all real numbers for both the domain and range. So just be aware of that. We are going to deal some with equations in standard form. So standard form is this form, ax plus by equals c. And this type of equation has two variables in it. We've again seen that. And so we can write these equations in standard form. An equation is in standard form if a few things happen. Number one, a and b are both not 0, meaning that if they were 0, you wouldn't have both variables, so you've got to have both variables. Also, there cannot be fractions if the equation is in standard form. So that's going to be important. And then the last note is that a cannot be negative. So I may ask you to take an equation and write it in standard form. When you write it in standard form, you have to put it in this form, ax plus by equals c, but there can't be fractions, and the a can't be negative. If that happens, if you have a negative there for that first number, or you have fractions, then it's not in standard form, even if it is in the right order. Okay, so that'll be important to us, again, as we move forward. So one of the ways that we're going to focus on graphing, previously in Chapter 2, we have talked about how to graph using a table. Making a table, plugging in numbers for x, solving for y, or vice versa. And we talked about how we could graph quadratics that way and cubic equations that way and so on. Well, now because we're focusing on linear equations, we can introduce some other ways to graph. Making a table still works. It is not necessarily, though, the easiest way to graph an equation. So one way is that we can graph using intercepts. In this diagram that I have to the right, the intercepts are where the line crosses the x-axis or the y-axis. And so you can see I've got those labeled on this graph. If you're wanting to find the order pair for the x-intercept, think about what that order pair would be. If the origin is here, if I ask you, well, how do you get to that point? And let's take out numbers for a minute and don't think about the numbers necessarily. If I ask you, well, how do I plot this one point that is the x-intercept, where the line crosses that x-axis? You would tell me, well, you go right some amount, and then you don't go up or down. And so if we were to put an ordered pair on that, we would say, well, we go right some amount, we'll call it a, and then our y value would have to be 0. Because if we go up or we go down, we're no longer on this x-axis. And so the y value has to be 0. And that is the case with that point, and that point, and that point, and all of these points that might be on our x-axis. Every one of those points have a similar order pair. It's some number, right or left, comma, 0. Now, think about the y-intercept. It's very similar. With the y-intercept, this point up here, if I ask you, well, how do you plot that point? Some of you are saying, well, go up. Well, okay, but let's think about it from an order pair standpoint. How much do I go right or left? Well, you ought to be saying none. So if you don't go right or left, well, that means that x-coordinate has to be 0. And then in this case, you would go up some amount. We'll call it b, because we don't have numbers listed here. And so every order pair that is on the y-axis has to have that same order pair. Because if you go right or you go left, then you're no longer on that axis. And so our point could be there, or any of these other points. And all of those have a similar order pair. You don't go right or left. You go up, or maybe you go down. And so when we talk about finding the intercepts of our graph, if I want to know the x-intercept, where this line crosses the x-axis, I'm going to take y, the y value, and put 0 in for it. Because I know that if the y value is 0, that order pair has to be on that x-axis. Very similar to what I'm going to do with the y-intercept. If I want to know the y-intercept, I'm going to put 0 in for x and solve for y. Because again, if 0 is my x value, then I know that point has to be on the y-axis. And so that's going to make finding the graph very, very easy if we are dealing with linear equations. So here's what we're going to do, and you can again see this, what we just mentioned. To find the x-intercept, this one that I've put in red, you're going to substitute 0 in for y and solve for x. To find the y-intercept, the one vertically on the y-axis, you're going to put 0 in for x and solve for y. And so that's going to, again, give us two very, very easy points that we can use when we begin to do our graph finding intercepts. So let's try one. So we're going to start with this equation, 2x plus 3y equals 6. And we're going to graph this using the intercepts. Now, you'll notice it says give domain and range. Kind of have already hinted to what domain and range probably are in this case, but we can still give that. It's not a big deal. So if we want to graph this, finding the intercepts, if we're going to take, let's do the x-intercept first. We're going to take 0 and put it in for y. So our equation that we're going to write is 2x plus 3 times 0 equals 6. That's going to guarantee that our order pair that we find has to be on that x-axis. And so then you're just going to solve for x. So this is 2x plus 0 equals 6. And 2x plus 0 is 2x. And then we'll divide by 2. And we'll find out x is 3. Now, x equals 3 is not the answer we're looking for. We're wanting the x-intercept. That is an ordered pair. And so you have to write your answer as an ordered pair. In this case, it is 3, 0. Now, do the same thing for the y-intercept. So for the y-intercept, we're going to take 0 and put it in for x. So we're going to say 2 times 0 plus 3y equals 6. And 2 times 0 is 0 plus 3y equals 6. And 0 plus 3y is 3y. It equals 6, and we'll divide by 3. And we find out y is 2. Well, again, y equals 2 is not what we want. We want the ordered pair. And so this ordered pair is 0, 2. Because again, we put 0 in for x. And now once we have these 2 points, now we can graph very, very easily. So our first order pair is 3, 0. So we're going to go right 3, which is going to be here, and don't go up or down. And then our y-intercept is 2, 0, 2. And so we don't go right or left any, but we go up 2 to that point. And now, because it is a linear equation, 2 points is enough to be able to graph. And so now we're just going to connect those. And our line looks something like this. Now, finding domain and range should hopefully at this point be pretty easy for you. So the domain is going to have to be all real numbers, because as you can see, this graph goes left forever and it goes right forever. And then the range also is all real numbers because it goes up forever and down forever. So it's everything from negative infinity to positive infinity. Now, I think you're probably going to look at that and say, well, that was pretty easy. Put 0 in for x, solve for y, put 0 in for y, solve for x. I can do that. Well, let me make it even easier. So if you'll notice, when we found the x-intercept, we put 0 in for y here. And if you'll notice that what happened here is 3 times 0 became 0, and 2x plus 0 is just 2x. So basically this term, this 3y term, just kind of goes away. And so from now on, if we're looking for the x-intercept, if you'll just think about covering up that term, so we're finding the x-intercept, right? So cover up y. In other words, put 0 in and it goes away. Well, look at the equation that's left. It's 2x equals 6, which is that equation. And then you just divide by 2 and you get your answer. So hopefully that's pretty easy. Now, let me erase that. If we are finding the y-intercept, again, if you'll notice what happened, we put 0 in, and 2 times 0 was 0, and then 0 plus 3y was just 3y. And so again, that term just kind of went away. And so if you're looking for the y-intercept, if you'll just cover up the x term, look at your equation that's left. In this case, it's 3y equals 6. Well, that is that equation. And then we divide by 3 and we get our answer. And so finding intercepts can be really, really easy, especially when the equation is already in standard form, where you're simply just going to cover one up, probably divide to solve for the other one, and hopefully that's not too difficult for you. If you have any questions about that, again, please email me, let me know, and I'll try to answer anything that you have. Now, look at these two equations. I would encourage you to pause the video and do the first one by yourself. We're going to do the f of x equals 2 in just a second. But I'd like to see you try to do this first one by yourself. So if you want to do that, pause the video. I'm going to give you 3 seconds to pause it. Alright, so we will go ahead and look at this first one. Again, the directions say to graph the function using intercepts. So again, we've talked about how f of x and y are the same thing. This may be easiest to rewrite it as y equals 2/3 x plus 6. May not, but for me, I prefer to write it that way. Because now, if I'm looking for the x-intercept, okay, so remember for the x-intercept, we're going to cover up that y value. In other words, put 0 in for it. And this would be our equation. And so then we can subtract 6. You get negative 6 is equal to 2/3 x. And we can get rid of the 2/3 by multiplying by the reciprocal, which same thing as dividing by the 2/3. So if you multiply by 3/2 on both sides, the 3's cancel, the 2's cancel, you get x. And on the right hand side, if you multiply straight across, you get negative 18/2, which is negative 9. And so the x-intercept is negative 9, 0. A little more difficult because it's not in standard form already. There is a little more work to do, but still got to solve for x. Now, to find the y-intercept, well, that's pretty easy because if you take this equation and you cover up your x term, well, the equation is simply y equals 6. There's nothing to solve, right? And so your ordered pair there is 0, 6. And so we can take those two ordered pairs, we can graph. The first one being negative 9, 0, we're going to go left 9 and don't go up or down any. 0, 6 says we're not going to go right or left, but we're going to go up 6. And so we should be able to now connect those 2 points and have our line that looks something like that. So that's the first one. And if your graph doesn't look like that, then it's wrong. It has to be that same graph. It can't go down. It can't be at different points. It has to be those specific points because those are the intercepts. And so our graph should be the same. Now, look at the next one. Again, f of x and y are the same thing. So if you write this as y equals 2, well, that probably makes a little more sense to us now. Because if y is equal to 2, what that means is that our y-intercept is 2. Now, you could look at this in a couple different ways. If you say, well, I don't know, you could memorize that if the equation is y equals a number, it is a horizontal line at that number. But I don't recommend you memorize it because typically people see y and they think vertical because of the y-axis. Or they see x equals a number and they think horizontal because x. And that's not right. So I would stay away from trying to memorize stuff. You could make a table. If you were to make a table like we did previously in chapter 2, you would say, well, on this table, I want x to be 0. Well, that's fine. There's no x in that equation because, again, our equation is y equals 2. But the y value has to be 2 because that's what our equation says. It says y equals 2, right? But I need more than 1 point, so I want x to also be 1. Well, in this equation, y is 2. Maybe I want a third point. I want x to be 2. Well, y is still 2. And so you could plot those points and get your graph. However, I really would just prefer that you know what this means. When you see this equation y equals 2, what it means is that the y-intercept is 2. It means it goes through the y-axis at positive 2. And because there's no x value in this equation, this line never goes down and through the x-axis. And so what it means then is that it must be parallel to the x-axis, which means it has to run horizontally. And so there's our graph. This line doesn't have an x-intercept. It only has a y-intercept. And so finding intercepts is a really great way to graph, but it doesn't always work. Because if the graph doesn't have an x and y intercept, or maybe it has an intercept that is through the origin, well, then that becomes a problem. And so this is one example of where we don't have an x and y intercept. Again, if you have questions about that, let me know. And so if you look at this one, by the way, this one asks for domain and range. So domain of the first one is all real numbers. Range is also all real numbers. Because again, it goes left forever, right forever. It goes up forever, down forever. And so domain and range is there. On this last one that we've done, the domain, again, you can look at the graph. It goes left forever and right forever. It is negative infinity to positive infinity. But the range value is just 2. So we can put that in squiggly brackets, and it is just positive 2. Because it doesn't go up and it doesn't go down. It just stays at 2. So just be aware of that. Alright, so on this one, it asks us to graph x equals 5. Well, again, this is another place, because there's only one variable, where we don't have an x-intercept and a y-intercept. And so again, you could memorize what this looks like. You could memorize that it's a vertical line at 5. You could make a table. I'll show you how that would work. If you say, well, I want to make a table. Well, in this equation, x is 5. And so what's y? Well, maybe we want y to be 0. No big deal. Well, I need another point because that's not enough to graph. And so in this equation, x is 5. What's y? Well, maybe it's 1. Well, it's always good to have a third point. So x is 5. What's y? Well, maybe it's 2. And you could plot each of those points and you would have your line. But again, I would prefer you just understand what this means. And so what this x equals 5 means is that this line has an x-intercept at 5. It goes through the x-axis at 5. But, like the previous problem, and by the way, we didn't plot these points on the previous one. You could have, and you would have had those 3 points. So just FYI. But on that problem, it only had the y-intercept, no x-intercept. Well, this one now has an x-intercept, but it doesn't have a y-intercept. So this line is never going to go through the y-axis in any way, in any kind of direction. It's never going to do any of that. And so because it doesn't, then it must be parallel to the y-axis. And so it's going to be a vertical line. Now, if you were to plot those other 2 points, we've got 5, 0, 5, 1 is here, and 5, 2 is there. And so again, you would see that you do have that same line. But I would just prefer you know what this means from the standpoint of when we see x equals 5, we know that means there's an x-intercept at 5. There's not a y-intercept, and so it must be parallel to the y-axis. Now, domain and range. Domain for this one is just 5. So I need to use a squiggly bracket, not a parentheses. So, keep my color here. So this domain is just 5, right? That's what our equation even tells us. Our equation says x equals 5. Domain is our x value. In this case, that's all it is. The range value, because it goes down forever and up forever, is all real numbers. Again, if you have any questions about any of that graphing with intercepts, please let me know. All right, so our last one that we're going to talk about with intercepts is a situation where you do have an x and y intercept because there's an x and y variable. But if you were to take, let's say, your x intercept, you're going to find it. Well, we've said that if you cover up that y term, our equation in this case would be 3x equals 0, and you could divide by 3, and you'd find out x is 0. Well, that order pair is 0, 0. Meaning this line is going to go through the origin. But, again, just like in the other two, that's not enough information. Because we don't know if the line does any of this. All we know is it goes through that point. We have no direction to it. And so because of that, we need more points. And so at this point, really the only way we know to graph is to make a table. And so we know it goes through the origin. If you make a t-table, we know 0, 0 is part of that table. And then we can put numbers in for x and solve for y, and vice versa. So I'm going to take 2 and put it in for x. And I'm also going to use negative 2. That way we see something on both sides of our origin here. So if you put 2 in, we have 3 times 2. Alright, so 3 times 2 plus 4y equals 0. And so that's 6 plus 4y equals 0. We'll subtract 6. And again, I assume you can probably solve this by yourself. We'll divide by 4. And so we find out that y is equal to a negative 3/2 when you simplify that fraction. Well, that's not ideal to have a fraction like that, but it is something we can do. It's not a huge problem, and so we'll use that in just a minute. Then for our third point, we're going to put negative 2 in, and so it's 3 times negative 2 plus 4y equals 0. And so 3 times negative 2 is negative 6 plus 4y equals 0. And so we'll add 6. And we'll get 4y is equal to 6, and we'll divide by 4. We'll get y is equal to 3/2. Again, not ideal, but it is still something we can graph. So I'm going to zoom this in a little bit so you can see how we're going to graph these. We've got the origin 0, 0 already. To plot our next point, it's 2, right 2, and then negative 3/2. So we're going to go right 2, and we're going to go down 3/2. Now you can literally count each half. So if you were going to do that, you would have 1/2, 2/2, 3/2. But you've got a calculator, so just punch in the calculator. If you don't know that 3/2 is 1.5, punch it in and see what you get. And so in this case, when you do, you'll see that it is 2, negative 1.5, which does put us at this point. Now, the other point is strictly a check point to make sure that they all line up. We've done this correctly. So we're going to go left 2, because it's negative 2, and up 3/2, or up 1.5. And so, again, there's that point. You'll see all 3 of those do end up on the same line. And so when we graph this, our graph looks something like that. We will continue in section